All right, class, welcome to lesson 5.4, 5.5 practice. So we're going to cover the questions on Canvas for the past couple of lessons. So let's go ahead and get started. So question 1, select all the angle relationships in triangle ABC that are correct. So we're going to see if the first one's correct. So looking at measure of angle A is less than measure of angle C. So remember, we're focusing on this triangle right here. That's what the question states. That triangle ABC. Okay, so then if we look at that triangle, if we look at angle A, that's angle A there, and angle C. Let's look at those. So if you want to compare those, remember, you're going to look at the opposite side, right? So you're going to look at the opposite side there, and that number is 3. Then you're going to look at the opposite side of C. That number is 3.1. So 3.1 is going to be bigger than 3, which means angle C is larger. Okay, so this is correct. Angle A is less than angle C. All right, so now let's check the next one. So using that same triangle, let's compare angle B to angle C. Well, angle C, we have 3.1. Opposite of angle B is 2.9. Those are clearly not equal, so it's not B. All right, let's measure angle A and compare angle A and angle B. 3.1 as opposed to 2.9. So angle A clearly is going to be bigger than angle B. So it cannot be C. All right, so angle A we said was bigger than angle B, right? So this is true. Angle A is bigger than angle B, and it is smaller than angle C. So this is correct. And we said that it's smaller than angle C, so this is not correct. Okay, so the answer is A and D. So number 2, select all the side angle relationships in triangle ABC that are true. Okay, so the largest angle is opposite the smallest side. So if you look at triangle, again, same triangle, triangle ABC, the largest angle, in this case, angle C, is opposite the longest side. This says the largest angle is opposite the smallest side. This is incorrect. The smallest angle is opposite the larger side. For the similar reason, that's incorrect. The smallest angle is opposite the smallest side. That is true. Angle, in this case, in this triangle, angle B is the smallest angle opposite the smallest side. The largest angle is opposite the larger side. That's true. Angle C is the angle, and this is the longest side here. The side lengths and angle measures are not related, and that is false. Okay, so the theorem that we're looking at here when we were comparing these triangles we called it theorem 5-9, and that is if you have a side that is greater than another side, then that means the opposite angle is greater than the other angle. So that was, I believe it was called theorem 5-9. So that's what we're referring to, and that was in lesson 5.4. All right, question 3. In triangle XYZ, suppose XY is less than XZ. What inequality relates two angles in triangle XYZ? So we have it helps to actually draw this out. So if you were to draw a triangle XYZ, now it doesn't matter how you draw the triangle, just label your vertices so that we can use this as a reference point. Now it says XY is less than XZ. So let's suppose XY is 5 and XZ is 10. 5 is less than 10, right? So in this example, we want to be able to identify, well, what inequality relates to angles? So is angle X less than angle Y? Well, angle X is here. And can we tell from this information that angle X is less than angle Y? Well, angle Y is opposite of that is 10. Opposite of angle X, we don't know. That's a question mark. They didn't give us any information on that. So we're not able to answer that question. So it's not going to be A. We don't have enough information for that. Now, angle X less than angle Z. Again, angle X, we have no information whatsoever about angle X. Angle Y. Is angle y less than angle z? Well, if you look at angle y, that's 10. Opposite of that is 10, as opposed to angle z, opposite of that is 5. So angle y is not less than angle z, it's actually greater than. Angle z is less than. So we're looking at D here. All right, question 4. What are the sides of triangle MNO listed from shortest to longest? Okay, so we're going to, this is the converse of the theorem 5-9 and lesson 5.4. So we're going to compare the angles, so look opposite of that angle. This angle is clearly the, well, we have to figure out all the angles first, right? So we know this angle, that's 61 degrees. And we don't know N and O just yet, right? So we're gonna need to find them. And the reason we're going to need to find them is because we're interested in that particular triangle for this example. But we do know that these are parallel. And so that's going to help us give us some information. So if these are parallel, well, then if this is 54 degrees, then this is 54 degrees. Why is that? Well, because those are corresponding angles. Remember, if you have two parallel lines and you have a transversal, then those are called corresponding, for example. All right, so we got that one, and then we can figure out the third one because remember, all the angles in a triangle add up to 180, right? So we have 54 plus 61, and we'll call this x for now. And the triangle angle sum theorem states that the sum of the interior angles of a triangle add up to 180. So this is going to be 115 plus x equals 180. And then x is going to be 65 degrees. So we can go ahead and replace this with 65 degrees. All right, so now we know what those angle measures are. So now let's look at which side is bigger. Well, clearly 65 degrees is the bigger angle, and so you're going to look opposite of that, right? And opposite of that is MN. So therefore MN is the number one, or well, is the largest, right? So that's going to be the number 3 line segment. And then 54 is, or 61 is the next largest one. So therefore look opposite of that. And that means that, well, let's look at this here. NO is going to be the second number in line because we're going from shortest to longest. And this is the smallest angle. And so this right here is going to be the number 1 in the rankings because we're listing it from shortest to longest. So that's number 1 is the shortest. So shortest is MO, followed by NO, followed by MN, the longest side. All right, question 5. Triangle has 2 sides measuring 8.5 centimeters and 15 centimeters. What is the greatest whole number length possible for the third side? Okay, so remember, if you have 8.5 and 15 as your measurements, and we have the third measurement, which we'll call x. To figure out the third measurement, remember, if you add these measurements, those measurements should always be greater than your third measurements when you add those first 2 measurements, okay? And that's the triangle inequality theorem. So if I add 8.5 plus 15, that should always be greater than my third side. So right here, this is my inequality there. And that third side should also be greater than the difference between those measurements. And that would ensure that you have the right measurements to make a triangle if you had that as your third side. Okay, so 15 minus 8.5 is 6.5. And this is going to be 23.5. Now, these are, of course, decimals, and they're interested in integers. They're interested in whole numbers, right? So what is the greatest whole number possible? Well, we know that x can't be 24 because 24 is larger than 23.5. So therefore, x would have to be 23, right? 23 would work because 23 is less than 23.5 and it's greater than 6.5. So that checks out. So the greatest whole number is going to be 23. So we're looking at the third side must be less than 23.5, and therefore the greatest whole number is 23. All right. Can each set of 3 sides form a triangle? So remember, if you're given 3 sides, remember what we said earlier, the triangle inequality theorem. If you add 2 sides, it should always be greater than the third side. So, and we're going to do this for all the sides. So 25 plus 12, is that greater than 13? And that would be yes. And then now you're going to look at another combination. So let's do 25 plus 13. That should always be bigger than the other side that you didn't use, which is 12. That's true. And then one more combination, 12 plus 13 is greater than 25. Is that true? Well, no, that would be false. So this is actually not going to be true. So therefore, this is going to be a no. You cannot form a triangle from those 3 sides. And then 3 plus 7, is that greater than 5? That's true. 3 plus 5, is that greater than 7? True. And then lastly, 5 plus 7, is that greater than 3? And that is also true, so yes, you can form a triangle. All right, 10 plus 15 is greater than 5. 10 plus 5, oh, that's not greater than 15. That's false, right? So that is the issue. The first one's good, but the second one is not. So this is a no. All right, that's all you got to do for that question. So given the following 2 sides, what are the range of values for the third side? And we kind of talked about this one already. Remember that the sum of the 2 sides has to be greater than the third side. So that means the third side has to be smaller than the sum of those 2 sides. And it has to be greater than the difference of the 2 sides. And so we have, this is going to be 23, and then this is going to be 3. Okay, so we got our numbers here. Question 8, select all the inequalities that relate the sides of the figure shown. So let's figure out which ones are correct. Now this right here, notice that these triangles in particular have the same set of congruent sides. So we have this one congruent to this one, and then this is congruent to itself, and then this is also congruent to this, right? So this is a hinge theorem problem, okay? So you're looking at a hinge theorem, and you're going to be able to compare the triangles directly using this information. Now this is 75. This is a 90-degree angle. Remember, because of that square corner that you see there, that's going to be 90 degrees, and you got 105. So now let's look at the opposite sides here. So the opposite side of 75 is A, or we're comparing A and B. So what we're doing is we're using the opposite angle of the sides. So we're comparing those, okay? So, and that'll tell us which one's bigger. So clearly 105 is the biggest, right? So that means C is going to be greater than B, and B is going to be greater than A because 90 is bigger than 75. Okay, so let's go ahead and look at those choices. So B is greater than A, C is greater than A. Well, that's true, because if C is greater than A and B is greater than A, well, that means that C is greater than A. That is called the transitive property of inequality. Okay, so just a side note. And then, so that's true. And B is less than C. B is less than C. And B is B between A and C. Well, is B less than C? Well, that's true. B is less than C. Is B greater than A? Yeah, that's true. So this is going to be true. But it's not going to be this one because B is not greater than C. B is less than C. So we got our answer choices. Next question, what is an inequality that relates KL and YZ in triangle JKL, triangle XYZ? So we're interested in KL and YZ. This is a hinge theorem problem because we have these sides matching up, and therefore we can compare them directly. Remember, if you have these 2 triangles and you want to compare them directly, you have to have some sort of theorem to use for that. So hinge theorem is what we're using. So we got 30 degrees here and 45 degrees here. So that means clearly 45 is bigger than 30. and therefore KL has to be greater than YZ. Question 10, select all the true statements. So we have here, notice that this is another hinge theorem like problem, right? You have these matching up, so we can use them. Okay, so let's see, let's select the true statement. So angle CED is equal to CAB. So CED is this angle right here. So the 5x minus 10. And that's equal to CAB. Let's see if that's true. CAB is this one right here. So how do we know those are equal? Well, if we're comparing them, remember, you're going to look at the opposite side. 12 is not equal to 10. So that means those angles are not equal. Okay, so this is false. All right, CAB greater than CED. So is it greater than that angle? Well, again, looking at those numbers, 12 is greater than 10, which means that CAB is greater. So that's true. Is BC greater than FG? So let's look at that. So BC is this line segment. Is that greater than FG? Well, let's look at the opposite angle here. So that's going to be 50 degrees. Opposite of FG is going to be this angle, but we know by vertical angles that's the same thing as this angle, right? So that's the 5x minus 10. But we just said that CAB is bigger than this angle, right? And so therefore, that means that if it's greater than, that means BC has to be greater than FG, which is true. Okay, but so that's the same by vertical angles right here. FG is equal to 10. Is that true? Well, let's go ahead and we're going to have to solve it, right? So FG is opposite of this angle, which we said by vertical angles is the same as that. Okay, so let's go ahead and solve this solve this to get FG. So we know that if this angle is okay, so then it turns out, so if you know that this is opposite of this angle, but it's the same as this angle, and this is opposite of the 10, well then that means that this has to be 10. Okay, so basically what we're saying is that these are actually congruent triangles, and you can think of it as because they're congruent because we got a side, angle, and a side, angle, and a side, because those angles are the same, and so therefore these triangles are congruent, and so FG is actually equal to 10, so that's true. And EG, now if you look at EG, this one right here, well that is related to, so if you look at that, so we know that this one was related to this one, that one was corresponding rather, and CE is corresponding to FG in this example. And so we don't know what CG is, but we do know that it's the same as in all three triangles here. And this is the measure that is 12. And so it can't be 12 if this is not the same side that we're looking at, which is BC. So BC is 12, not AC, and therefore EG cannot be 12. Okay, so basically these in this triangle 1, triangle 2 are congruent, but they're not necessarily congruent to this one. They're not congruent to the left one. All right, question 11. Write an inequality, or this would say an inequality, to describe the possible values of x. Okay, so we're interested in the 5x minus 10 to figure out what x is. So if you look at this, well, this right here is opposite of the 10 side. And if you compare that to the 50-degree angle here, well, this 50-degree angle is opposite of the 12 side. And so if you compare 12 with 10, well, 12 is greater than 10. And so that means that 5x minus 10 has to be greater than 50. All right, so we have 5x minus 10 is greater than 50 degrees. And then we can go ahead and add 10 on both sides. So 5x has to be greater than 60. And then we can divide by 5. X has to be greater than 12. Okay, so we got one of the solutions here. X has to be greater than 12. Where does the other piece come in? Well, you also have to know that, well, this angle is limited in how large or how small it can be. So the largest that this angle could be is just below 180. So this has to be less than 180, but it also has to be greater than 0. The smallest that it can be is just above 0. So which one are we going to use? Well, we already know that x is greater than 12, and therefore the fact that it's greater than 0 is useless because 12 is already bigger than 0. So we're going to use this inequality right here, and we're going to solve it. So we're going to go ahead and add 10 on both sides. So this is going to be less than 190, divide by 5. So x is going to be less than 190 divided by 5. 5 goes into 19. Not quite 4 times, so 3 times, so about 38. All right, so we got x is smaller than 38, but greater than 12. All right, write an equality or inequality that relates angle B to angle D. So we're interested in angle B, angle D. Okay, so well, we know that 5x minus 10 is greater, right, than 50. So, or rather, it's smaller than 50. So we said that 5x minus 10 is smaller than 50. So this right here is smaller. This right here is larger. And we know that this angle right here, those are equal measures. They're congruent. And so if we have an equal measurement and we have one that's larger, one that's smaller, well then that means that this, because this is smaller, this has to make up for it by being larger, right? And because this is larger, this has to make up for it by being smaller. But that only works if this is equal, right? So here's an example. If we know that the larger one was 50, which we know it's 50 here, and this is going to be, let's say, 40 instead of 50, because this is, let's do this right here. Let's assume that's 40, and we'll assume that's 50. Well, then we got a 50 and a plus a, let's say these are both 30 to make them equal. And then my blank is the angles that I'm interested in, angle B and angle D. Well, we know they have to add up to 180. So 50 plus 30 is 80, so then that means this has to be 100. So because this 50 is larger, it makes this number drop to 100. Now, because this number is small, this is 70 now, this number has to be increased to make up for the decrease in the 40. So therefore, this is larger, right? And that's exactly what we're saying here. D has to be larger to make up for the fact that this angle was smaller. All right, so angle D is larger than angle B, so therefore angle B is less than. All right, guys, that's going to do it for the video. I hope you found this useful, and as usual, I'll see you in the next one.